Good day, Abid to Dr. Tamiro. My name is Hilman Yassin and I will begin to present our group mechanical system design of mini hydropower at Post Hendrop Guamusan Kelantan by using Archimedes screw turbine concept. The outline of presentation. First is introduction covered by me. Second is component selection presented by Hamizan Mukri. Third is engineering drawing presented by Ahmad Fuad. Fourth is project costing presented by Faiz Farhan. Next is project management presented by Imran. And lastly, conclusion covered by Amir Koyum. Introduction of the project background. First, electric is an important source of energy that are used throughout the world. They're used by household for daily life, industry, and public facilities. The sources of electric come from three major categories, such as fossil fuel that consists of coal, natural gas, and petroleum, nuclear energy, and renewable energy source. Hydroelectricity means electric is produced by transforming mechanical energy or kinetic energy into electricity by utilizing water sources. From the discussion among our group, we decided to choose the concept of Archimedes screw turbine for the hydropower plant. Archimedes screw is used to convert the potential energy of water supply into kinetic energy. This is because the design are eco-friendly, fish-friendly, non and non-polluting renewable energy sources. Furthermore, the design are low cost of the construction and maintenance for each component, making the mini hydroelectric power generation to be reliable and efficient form of clean energy. Problem statement for our studies are: from our study, we found out that there is community at Post Hendrop Gomusan Kelantan have a difficulties of electricity supply for their daily use. The community in Post Hendrop does not have electricity supply for their daily usage and community activities. The people use conventional diesel generators to generate electricity for about 30 years without any assistance of authorities for 24 hours electrical supply. Moreover, the cost to buy diesel fuel to power the generator is more expensive compared to electricity costs in developed area. Next is objective of this project is to apply the concept of hydroelectric in Post-Hendrop community, and second is to provide electricity for the common facilities in the rural area. Next, as the site location for the construction will be at Post Hendrop Gomusan Kelantan and the river source comes from the Sungai Bro. The area of construction plan will be on the highlighted area in the image from satellite view. This project will solve the difficulties faced by the community at the area that does not have 24 hours electricity supplies, and it will benefit the community that consists of about 1,000 people. And the objective construction of Archimedes screw turbine at site location are to provide additional or backup power in case of emergencies, provide energy to light up more common facilities, improve living standard and economic development of rural area, and lastly, to generate electricity for about 100 kilowatt to 1000 kilowatt. That's all from me. Next, I will pass to Hamza Mukri for component selection. Thank you.
Hello and a good day. My name is Mawad Hamizan Mukri bin Bisnan, and I will be presenting about component selection. In the component selection of mini hydroelectric at Post Hendrop, this is the general specification as you can see in the slide. For the project identification, the description is the mini hydroelectric power generation plant. The basic function is to generate electricity. The special features is the Archimedean hydro screw turbine, and the key performance is to generate electricity from 100 kilowatt to 1000 kilowatt. Second is market identification. The market target is for the federal agencies, political parties, and local community, as well as in the universities. The product exists in the market for the all the component is exist in the market. And the competitors in the market identification are Electron Technology Sdn Bhd, where they build mini hydroelectric power in other states. Third is the life cycle. The life cycle of our project is up to 8 years. The minimum is 5 years and the maximum is 10 years. And the total cost of installation is 2 million ringgit Malaysia. And lastly, the social, political, and legal requirement for our project. The intellectual property is not registered yet. For the approval, the Perak state government have to be approved for our project to commission. And the off-taker is the Tenaga Nasional Berhad, where the TNB will provide the commissioning parts for our hydroelectric power generation, as well as the renewable energy power producer REP PAPA signed by Tenaga TNB and fit in tariff and fit in approval by SEDA. That's all, and moving on to the next slide. Continue on to the next slide. In this slide, I will explain about the system flow. For our mini hydroelectric system flow, first, the water intake. The water from the river is flowed in the water intake and flow through the river channel. And from the river channel, the water will meet the stop lock embedded with concrete. The stop lock function is to control the flow of the water that pass through the, and then it pass through the coarse screen woven wire, where the coarse screen will filter all the debris or all the dirt and filter only the clean water will pass through the coarse screen woven wire. And then it pass through the vertical rising sluice gate. The vertical rising sluice gate is to also control the water flow rate. Then it passed through the weir and rock ram fishway. The weir function is to increase or decrease the flow rate of the water, while the rock ram fishway is for the fish to swim through the or pass without getting caught in the Archimedes screw turbine. And after the weir, the water will flow through the Archimedes screw turbine, where the turbine will generate kinetic energy and convert to mechanical energy, and the mechanical energy will rotate the grid coupling, also rotate the gearbox KVEZ 60T gearbox will rotate, and also and pass through the grid coupling will rotate also. And after that, the rotation will rotate the motor and stator in the generator. The rotation of mechanical energy will change into electrical energy, and the electrical energy that generate that that generate will will pass to the transmission substation and the transmission line, and then pass to the housing area. For the water after passing through the Archimedes screw turbine, we will pass through a concrete base, and then discharge channel. Lastly, the vertical rising sluice gate and out for the river. This is our simple system flow for our mini hydroelectric power generation. Moving on to the next slide. This is the same explanation from the previous slides, In this slides, I will present about the function of each component used in the mini hydroelectric power generation system. First, the Archimedes screw turbine. The efficiency is up to 90% and remain constant with varying load. It is easy to install. It is easy to install a factory pre-assembly and need less civil work. It is environmental friendly. Second is the gearbox. The gearbox used is KVEZ60T. With the gearbox use a bevel helical gearbox with an input speed of 700 and output speed is 770 with a multiple of 100 output speed, 100 times output speed. Third is the coupling. The grid coupling able to transfer power from driven to from drive to driven, from drive to driven with a with 30% reduction of vibration. This mean that the grid coupling will have less vibration to transfer power from drive to driven. The bearing used is the SXL turbine guide bearing with a benefit of no complicated oil or grease system requirement, and it is easy to access and maintain. Next is the sluice gate. The vertical rising sluice gate is able to completely seal the water if needed. Then the stop lock embedded in concrete is a strong and solid structure for minimize the leakage. If water to pro is this is also to prevent water from leak if the flow rate is over the requirement. Next, the cost screen bar X or bar screen. The function is to filter the debris from river while allowing the fish to pass through the screen. And lastly, rock ram fishware. This is specially made for a variety of fish to swim into this opening and to prevent the fish from getting caught in the Archimedes screw turbine. And that's all from the component selection that we choose for our project. This is the component selection that we choose is based on our discussion. Each of the component that we select have been through a delicate and detailed decision to make this project a successful. We choose a very important part to assemble the mini hydroelectric system. That's all, and I will pass it to my friend for the next presentation.
For the next part of our presentation is engineering drawing. So for this project, we have done several engineering drawing of the important component and assembled them together to form our completed hydropower plant. And some of the components that we draw includes turbine structure, gearbox, generator, shaft, and also coupling. Before we done our engineering drawing, some of the calculation is done to find the required specification of the component in order to get our desired output during our assembly, so that and our system can run smoothly. So for the next part, next slide, we show some example of the specification for the project. Here are some of the specification that we have done in this project. One is for gearbox and the other one is for the turbine. So within the gearbox, the specification are the pitch diameter of the gear, number of teeth. So the number of teeth is important as we need to manipulate our rotational speed of the shaft so that it will be suitable for the generator to generate our required output. And for our next specification is the turbine. For our turbine, the angle of the platform will be 22 degree, the bladed length is 6 and the turbine diameter is 2.6. All of this specification will affect our all of this specification will affect our calculation on the output of the power generated by the turbine in our system. So from all of the specification, we will draw a suitable design for the component. For the next part, I will show some of the engineering drawing that have been done during this project. The first and second is our gearbox and the gear assembly inside of the gearbox. And next is the stop lock and sluice gate. And the next part is turbine structure and also the turbine. Here we can see from the specification is that the platform angle will be 22 degree and also the turbine number of bucket is 8 and the total length of the bladed length is 6 meter and also the diameter is 2.6 meter. And lastly, for our drawing is the assembly drawing where we assemble all of our component drawing into one drawing. So from this drawing, we can see we use 6 pair of all component to create our hydroelectric plant. As you can see within this slide, there is 6 turbine, 6 stop lock, and also 6 of other component to get our desired output.
Hello, my name is Muhammad Faiz Farhan bin Zakaria with ID 24233. Thank you for giving me chance to present about the costing. For this project, there are two major costs, which is the CAPEX and the OPEX. The OPEX is the operating expense which is an expense required for the day-to-day functioning of a business or project, while the CAPEX is the capital expense, which is an expense a business incurs to create a benefit in the future. Next, there will be another major consideration for the cost estimation. Firstly, the economics to scale. Since the project requires a big amount of money and there are no sponsors, it is funded by the bank's loan. Although there will be the payment interest, a proper financial planning and estimation has been done wisely. The profit of this project comes from selling the generated power to the Tenaga Nasional Berhad. The second one is the geographic factor. Since the site of the project is located in a remote area, there will be an additional charge since it is not easily accessible. The additional cost also comes from overseas shipping costs as some of the equipments are not available in Malaysia. Lastly, as the installation need an expert, there will be another additional fee and another additional cost as there is no available local experts. And the last point is the seasonal effect on work. Since the site is located in the east coast area of Malaysia, it is exposed to the monsoon season in the end of the year. This can cause the delay in work progress, which will contribute to more cost consumption. For the next slide, it is about the overview of labor, materials and indirect costs. In order to make a good cost estimation and planning, it is estimated based on the previous project data. It will be covered by all the costs, which including the labor allowance and the material costs as well. So by using the previous data, there will be a more accurate costing estimation for this project. For this slide, this is a capex for this project, which is about 650,000 ringgit, and this is the capex, or this is the OPEX calculation. The table show one part of the operational cost, which is 418,307 ringgit. And for this slide, this is the full calculation of the total OPEX per year, which is about 48,030 ringgit. For the cash flow and payback calculation, there are two assumptions, which is the power generated will be sold at the price of 30 cents per unit of kilowatt hour for daily operation throughout the year, and uniform series of loan payment with the interest of 6%. Based on these two assumptions, the cash flow and the payback calculation of the costing can be calculated and estimated accurately. Based on previous calculation, it is expressed into these two graphs, which is the cash flow diagram and the payback period diagram. From the assumption of 6% of interest loan payment, it will take just 5 years to settle all the bank's loan. So it can be assumed that this project is cost feasible and it can be sustained throughout the rest of the years. Okay, that's all from me. Thank you.
Okay, Bismillah. Greetings. My name is Muhammad Imran bin Muhammad Asri. My matrix ID is 24344. So I'll be presenting about the project management, which covers the project organization. Second is Gantt chart, and third is the network diagram. So if you can see from the organization chart, we'll be having 8 people which will lead the project. First is the president, which is by Ame, and then human resource and administration, which will be handled by Hilman, and then design engineer, which is Hamizan, operation, which is Faiz, procurement and finance, Fuad, and project manager, Imran, myself, and mechanical engineer and also electrical engineer, which will be outsourced. So next, regarding the roles, the president, he will lead and supervise the project from the beginning until the end, and he will also connect with the stakeholders lah. And then the HRA, human resource and admin, he will manage the human resource, administration and also paperwork. Next is the design engineer. He will lead the design of the hydropower plant. And then the operation, this position will assist in the operations of the project. Procurement and finance, this position functions as a procurement manager of project and also as the finance. And last one is the project manager, which is planning, lead the engineers and technicians of the project, organize and also control of the project. So next slide. So now we'll be going to the Gantt chart. This is the Gantt chart. So the first stage is planning, which we'll be having first is site visit, and then the design of the plan based on the site that we visited, and also calculation of the costing, planning of the manpower and also materials planning. And then the second one is we'll be buying or procurement of the materials lah. And then the third is mobilization to the site. The mobilization will be divided into three, which is the manpower, the crane, excavator, tools and vehicles, and lastly is the materials. So the manpower will be mobilized first. Fourth is the clearing of the site. Fifth is the building of the temporary dam. We will deviate the water flow, and then we'll be building the temporary dam. The sixth is the foundation building for the hydropower plant dam. So first we will excavate the foundation, and then we will be forming the basement walls, and then we will having placing the concrete, and then we wait for the concrete to cure, which will take around 1 week, and then we strip the basement wall, which is made of wood lah. The seventh is building the support structure, which is scaffolding, steel caging or rebar, reinforcement bar, and then pouring concrete, and then electrical wiring, and lastly is the waiting for the concrete to cure. So this is the last part of the Gantt chart. The eighth step is the installation of the gearbox, shaft, generator and turbine, which will approximately take around 2 weeks. And then the ninth step is testing, which will do small scale testing and then the full scale testing. And then the 10th step is the full operation or the commissioning of the dam. It also have the opening of the temporary dam. We will disassemble of the temporary dam. So the last one is the project handover to the client. Okay, for the last slide, this is our critical path diagram. So the whole diagram is called a network diagram, which is defined by a network consisting of two basic elements, nodes and arrows, or links between the nodes. So what is a critical path? A critical path is the longest series of all the activities and also set the project completion time. It must be carried out exactly on time, otherwise it will cause our project to delay. As you can see in the diagram, this is our critical path, which is in the red arrow. So in total, our project took 81 weeks to complete. So if you can see from the red arrow, first we'll start from A, and then C, D, E, F, G, H, I, J, L, and ends with N. So this is our critical path. So that's all. I pass to the next member.
For the conclusion of this project, the objective of this project is to study, observe, and design a mini hydroelectric station in order to convert the potential energy of water supply from a river into kinetic energy, which would then be used to provide electricity to common facilities in the rural area. The datum was constructed by doing a physical and functional decomposition in order to generate the individual concepts. After the completion of designing the components of the project, proper dimensioning and constraints were able to be determined, which allows the sub-assembly to be constructed and later being added to the final overall assembly. In order to plan out each step of the project's execution, project management was done in a detailed manner, and it is completed within the planned timelines. The main objective of designing a mini hydroelectric plant had been achieved. So that is all for our project. Thank you.